If I stand on the third-story balcony with a spoon and I let go, we all know what will happen, right? The spoon falls because the Earth's gravity creates potential energy, and once I let go of the spoon and it is able to fall, the potential energy causes it to move quickly towards the ground. But we're here to talk about voltage, not falling spoons. When we think of potential energy, we usually think of lifting an object in a gravitational field so that when released, it falls back to the ground. But voltage is actually another type of potential energy. Voltage is electric potential energy, and it happens when we move an object in an electric field. When released, the object will fall to the electrical ground. At the atomic level, particles can be negatively, positively, or neutrally charged. Normally, we might expect these particles to be somewhat evenly distributed. But if we could separate them, the positive ones over here and the negative ones over here, as if we were picking teams for a game of subatomic dodgeball, then we would have an electric field. But remember, this separation is unnatural. The particles want to mix, and positive wants to be near negative, and vice versa. So a negatively charged particle that enters the electric field will quickly move to the positive side, almost as if it was falling. The voltage or electric potential energy that's created by this separation of charges is based on this equation. It is related to the strength of the electric field and to where the particle is placed in that field. One place that you might experience voltage in real life is a battery. Inside a battery, the positive and negative charges have been separated with a divider in between. They stay separated until you connect them together through the wires of the device that you're using. Then over time, all the negative electrons flow through to the other side of the battery, doing work along the way. When they've made it across, there's no more potential energy, and the battery is dead. Which brings us to the most important thing about potential energy. Potential energy means the potential to do work. So a great analogy for a battery is a water wheel. A water wheel uses the potential energy from gravity to do work as the water is falling. Similarly, a battery uses potential energy from separating electric charges to do work. The electric current, or flow of electrons, is analogous here to the flow of water. Some materials allow more current to flow than others. For now, you can think of this like the thickness of the pipe through which the water flows. A thinner pipe would resist the flow more, so we call this resistance. This gives us the intuition for a fundamental equation, Ohm's law. Here, more voltage will create more current. As you can imagine, lots of water flowing from a huge waterfall and a little water flowing from a small waterfall. But the flow of current would decrease if there was more resistance. You can imagine this like a waterfall that falls unimpeded by rocks versus a waterfall that's full of rocks and leaves and other things preventing the water from flowing. That's all for now, friends. If this video was helpful to you, please like, leave a comment, or even share with a friend. You can subscribe for more videos on electrical engineering concepts. Thanks for watching.